Welcome to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, well, I'm just going to remind you the 3 books that are on sale. Drink tea and read the paper. If you're a green belt and a black belt and you want simple instruction on how to apply your skill, design of experiments for 21st century engineers, and finally, a statistical process control for small batch production. They are all available from lulu.com and the links are in the video below. Welcome to Complexity Made Simple. My name is Paul Allen and the topic of today's newsletter is how to design great control standards. You've got a process, you need to put controls in place. How do you do it so you get true process control that's easy to maintain and understand? So we're going to take a look at process control standards. How to design a great standard. So a couple of things to say about getting a process under control. First of all, let's put our money-making process down. Every process is the same, folks. You've got a money-making process. It's got inputs. You have to fix the inputs somewhere. Here's our money-making process. How do we design great standards so that it's clear and unambiguous? Obviously, we've got some outputs over here. What are we trying to do with the outputs? We're always trying to please the customer over here. Okay, so we're trying to put great controls in place so that they work really well. So let's talk about what a great control looks like. Well, to have a variable, to have an input under control, you should have a standard. I'm going to call it a standard operating procedure. You should be happy with the standard. You should be happy with it. And finally, you should use it. If you don't get a tick in all 3 of those, then you don't have the variable under control. You don't have the input under control. So you must get a tick in all 3 regions in order to say that the process is under control. Okay, so where it typically goes wrong is these 2 here. People either write half-arsed standards or they don't use them. They like to write concessions and just say, it'll be okay, or we'll let the operator just find his own way, this type of thing. But here's where control typically goes wrong. We don't write good enough standards or we don't use them. What I want to just talk about today is how to write a great standard. So things to avoid. What I want you to avoid are things like, I don't know, adjust the machine until you're happy. Yep, I've seen standards like that. Adjust the machine until you're happy. What's that saying? It's basically saying, we haven't got a flipping clue. Play about with the machine until something good happens, will you? It's no standard at all. Alright, so we want to get standards which are clear and unambiguous. Now this is especially important when we are talking about dials and settings on the machine. So I want to talk about how to get a great standard when we're talking about dials and settings, and some behavior that you want to definitely avoid. Now the one I'm going to use, which is a nice example, we're going to use water temperature as an example. And of course we've got a setting over here and we've got a temperature that we're going to get over here. So I want to show you what happens and why this often goes wrong, because we don't get the right standard. Okay, so let me show you what we're going to do. So we've got water temperature. So here's the variable. Water temp. There's a dial on the machine. Operator's got to set it. It's very straightforward. All we have to do is tell him a number, give him the number, and let him dial it in. So let's give him a number. We're going to say we'd like you to hit 40 degrees centigrade. Okay, and obviously over here we're going to have water temperature. We're going to have water temperature over here. Now, of course, what do you do next? Once you've given him the 40 degrees, what do you do next? Well, the next thing you think about is a tolerance. Okay, a tolerance. Now then, folks, the tolerance is a mistake. You don't need a tolerance here. Is it possible for him to dial the setting to 40 degrees, take his hands off, and the setting will stay at 40 degrees? It doesn't move, does it? No. Why does he need a tolerance? He doesn't. Process doesn't move. Okay, however, our money making machine has got thermostats and it's got heating elements, and people are opening the door, and maybe fresh water's being put in the process, and all kinds of things. So if we go to this end of the process, what's going to happen this end? Well, this end, of course, the 40 degrees, maybe we'll hit 40 degrees on the average, but we won't hit 40 degrees all the time. So what we'll get, we get a little bit of wandering. So what do we need this side of the process? Well, a tolerance might be useful. Yeah, because we can't hold 40 degrees. Now let's say in this case the tolerance is plus or minus 5 degrees. That's what we decide we're going to put on the process. Now here is the biggest mistake you can make, because where do you put the plus or minus 5 degrees now? The plus or minus 5 degrees is for the machine. The plus or minus 5 degrees is for the thermostats and all the process and everything that's working. That's what it's for. What the plus or minus 5 degrees is not for is the operator over this side. He doesn't need a tolerance because he can perfectly easily dial it to 40. But now what you do is you add the plus or minus 5 degrees over here. That is a mistake. It's not necessary. He doesn't need a tolerance. Now, you gave the plus or minus 5 degrees to the machinery and its ability to control, because it can't keep the thing perfectly in place. You've taken the plus or minus 5 and you've given it to a dial that was perfectly stable. Now what does the operator do? Well, the operator notices the process going up and down, and what does he do? He now dials in plus or minus 5 degrees this end. So you used to have a process that looked like this. Just dead on 40 degrees. Not a problem. You used to have a process that was very stable. Now that we've given it a plus or minus 5 degree tolerance, this thing gets wound up and down by plus or minus 5 degrees. Well, if I take plus or minus 5 degrees and I add the variability that the process is going to put in, what do I get over this side? Well, now I don't get plus or minus 5. Maybe I get plus or minus 10. Doesn't quite work like that, but you're going to get close to plus or minus 10. You've just created a standard that we're not happy with. Why did you do that? Only give a tolerance if the item that you're looking at cannot hold in that position. So for example, if you said the filter, the flow through a filter, and you said, well, when we clean the filter out, we would like the flow to be at a particular level. And then you know that the flow will degrade to a point, then it's time to clean it again. Now in that case, you can't hold that tolerance. You can't hold it. It's exactly a particular flow, it would be wrong to try and specify it like that. But in this case, if I dial the thing to 40 degrees, take my hand off the dial just stays at 40 degrees. I don't need a tolerance. Don't give them when they're not necessary. What tolerances do is create acceptable variability, and variability kills process performance. What you want to do is put great, clear and unambiguous 40 degrees. That's it. It is clear and unambiguous. Clear and unambiguous are world-class standards, and if you use them, you'll find your machine will work perfectly well.